Hey, 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 happy Saturday, Friday, who cares? It's all good. It's a weekend, that's what's important. Hope you're all having a good one. I just got slaughtered in Overwatch so many times. It's the start of the new season, so bad. And now I'm here to slaughter some code to make me feel better about myself. So welcome, welcome. Hope you're having a good one. And it looks like we have another easy problem where we're given an array of coordinates, x and y, and we need to check if these points make a straight line. And I think we can tell that by just looking at 2 points. We figure out the slope, the change in x and y, and then if we see any points in that, or in the rest of the array that are not aligning with that ratio, then it's done. There's no way to do this without looking at every element. Well, that's not totally true. I mean, you stop as soon as you see one that makes it not align. But worst case scenario, you have to check all. So there's no way I can think of to do this in less steps. You saw not to get a bigger. I don't think you can beat that big O time. Yeah, nothing fancy there. We got a couple constraints. Nothing I'm really too worried about. I mean, I think we can just kind of take a look at 2. And if we only have 2, then we're done. In this case, we figure out the change in x and y. Oh, I guess we have to worry about, we don't know the order of the elements. So it doesn't tell us that they're in the right order. So for example, if we imagine this one was first and this one was second, then here we would figure out the difference in x is 3 and the difference in 5 and 2 is also 3. So if we reduce that, then we get 3 over 3, so we know that the slope is essentially 1 over 1. So then we can look at any other item in here and figure out if that's the same ratio, say from this one to this one. So that's a little funky. So let's say I figure out the 3 to 3 ratio. Then I look at this one. I need to know that it's a 3 to 3 ratio with this one. And it is. How do I tell that also with this one? So here I could do 6 minus 1 is 5, 7 minus 2 is 5, and I know those divide to 1. So that's good. So one by one, that's pretty easy. But what if the slope were like 2 over 1 or something? Does that make sense for us to figure out that slope as like or to reduce that slope is basically what I'm trying to figure out. Like, let's pretend it wasn't 1 over 1, it was say 3 over 1. Or maybe that's not even a great one. What about 3 over 2? Because it doesn't divide evenly. I also have to worry about positive, negative. I think I can deal with that with the absolute value, as long as they're totally mismatched. Like if it's positive x, negative y, then a negative x, positive y would work. Nothing else would work. So we could get that from absolute value. Was that true? I don't know if that's true. I don't know. Oh, we got hints. I don't know. I don't know if I want to take the hints. I don't know. Yeah, let's go for it. If there's only 2 points, return true. Okay. Check if all other points lie on the first line defined by the first 2 points. Okay, yeah. Use the cross product to check collinearity. So if I have 2 fractions, cross product means multiplying the top by the bottom and seeing if that equals the top minus the bottom. Oh, that's slick. Yeah, okay. So this hint number 3 has been worth its weight in gold. Yeah, the cross product. That's smart. That's very smart. I was starting to think about all sorts of weird things with trying to figure out the absolute value and if that's totally true or whatever. But yeah, just the cross product should work out okay. Yeah, that's slick. Do we need to bust out IntelliJ for this one? Yeah, let's do. Because we can write, let's see, we can write a test function for, as they called it, collinearity. Linearity. I don't know how they spelled it. All right, let's just delete all this stuff. All right, whatever. How did they spell it? Let's get educated. They got 2 L's. All right. Let's get that fixed. Okay. We're on the right path. Grab this, and so we got an int array coming in. Get rid of the compiler error, and what do we want to do here? I'm gonna make a separate function called isCollinear, and it will take. Hey, how are these coordinates? This is weird. An array of int array. So they're giving me a bunch of arrays with, and I guess the int array only has 2 elements in it. At least better. So I guess I'll take in 2 int arrays, which is odd. I'll take it though. Okay. And I'll return true. But in order to do that, I also need to take a ratio. What's that ratio? Yeah, so maybe this function isn't great. I'll have a function that returns instead an int array. Why not? Called get slope. And what we'll do is a at 0 times b at 1 and a at 1 times b at 0. I hate this being an array, but at least it's consistent. I like consistency more than things I dislike. Can you not create an array like this? Collection literals outside of annotations. I just do like array of. There we go. Kotlin to the rescue. All right. Let's see what we get here. Get slope. And if I pass, let's see. Array of. Let's use their example. An array of 1 and 2 and an array of 2 of 3. Okay, so now if I get the slope of these guys, then what are we going to get? Result at 0 should equal the cross product. So 3. And something else. Can I just do a search here like this? 3 and 4. And do I want to reduce this? I don't want to reduce. I don't want to do. Let's be lazy. Sort values equal. Is there an array equal? Aw, come on. Fine. Result at 0 and 4. Let's call this one a simple example. Sure. And these tests aren't not very important. I don't expect them to fail, except when they do. An int array. I don't want to pass an int array. Oh, I heard a noise. I don't know what that noise means. Somebody smashed the downvote. Oh, it's a like. Thank you. I've never heard that before. No one's ever liked a video. Thank you. How do you create an int array? Ugh. Maybe there's something we can do where you do like array of, it should be integers, and then can I do like 2 int array? Yes, yes. Okay. Thank you, Kotlin, for encouraging my laziness. All right. Still more lines than I'd like to see, but yeah, I don't know. I don't know how else I could really do that. I don't want to do it in my my code up here. This is going to be pristine. So yeah, this test is pretty much worthless, but I have a feeling we're going to end up changing this to maybe reduce or something, so it'd be nice to have a couple tests kind of set up. Verify we're not breaking anything. Let's see. Let's get an example that could be reduced. So if I said, I don't know, maybe 1 to 9 then I expect the result to be 8 which could reduce, but it's currently not, and that's fine. That might be good enough. Oh, because it's multiplied, and I did a minus. I don't know. I'm crazy. Alright, now this is going to pass, and now we can write another function called, let me close this. What do we want to call this? Is collinear. And it will take 2 slopes, which I currently have as being whatever type this is, an array of ints. What is an int array? This is like Kotlin int array. That's weird. I don't know the difference between an int array and an array of ints. Oh, I mean, okay, whatever. It seems like int array is a little bit more specific, a little bit more Kotlin-like, and it translates to what I expect in Java land, so I guess I'm just going to be okay with it. just wish I could do like int array of. All right. So here we'll take two int arrays. And we'll consider them collinear if the ratio is the same. How do we tell if the ratio is the same? I'm going to write it poorly, and then maybe we can make it better. If A at O equals B at O, and A at 1 equals B at 1, but this only works if they've been reduced. So what do we want to... I think it makes sense to handle that reduction in the slope. Alternatively, is there some way to find out if these are all divisible by each other? I don't know. Well, first of all, get slope. No wonder I was confused about the answer here. It should be 8. My get slope is doing the cross product, which doesn't make any sense to me. That's not right. This is where cross product comes in. So if the cross product is equal, then it's collinear. So collinear is easy. And then get the slope is really just A at O minus A at 1, sure, and B at O minus B at 1. Wait, what? No. AO minus BO, and then A1 minus B1. So up here, yeah, let me reverse these, just because it reads a little better, I think. Oh my gosh, I keep doing the same thing. B minus A, B minus A. All right, so here it's 2 minus 1, 3 minus 2. So we should have got 1, 1. And here we should get 8, 8. Let's try these tests again. Okay, now we're on the right track. Happy Friday. So now collinear is if these two numbers are equal. Is that true? So if I have a 1, 2, and also a 2, 4, then this collinear check is going to do 1 times 4, yep, and 2 times 2 equals 4, so that worked out. What about a 1, 1 and a 3, 3? Same thing, yeah, 3 equals 3. What if this was a negative 1, negative 1, and a 3, 3? In that case, it'd be negative 3 equals negative 3. So that's really sick. I didn't realize that you could tell if two numbers have the same ratio without trying to find like a common denominator, or trying to reduce that fraction. You could just check the cross product, which, assuming it's not going to overflow 32 bits, which I believe they told us right here. They don't tell us, actually. Oh, yeah, 10 to the 4th. It's a weird way of writing it. Very mathematical. Okay, and they also mentioned we don't have to care about dupes, which is nice. Alright, so we're happy with the slopes. Now we can do fun test collinearity. Sure. And what we'll do is just do those couple simple ones. Let's see, solution. Ugh. Int array and 100, 100, sure. And we'll do a couple more of these. I know you're not supposed to do multiple certs, but you know, it's Friday. I think you're allowed to do stuff like that on Fridays. So a 3 and a 9, sure. Let's test the negative case. So 1, 2 should also work, I think. No, 1, -2 should work. All right, hey, looking good. So now we can actually solve our problem. Solve our problem. So what we could do. Did they say anything about guaranteeing us? Yeah, they're going to give us at least 2. So we're going to assume it is a line. And we'll return is a line. And then, how do we want to do this? I kind of just want to say, like, get the slope of, get the slop of, get the sloop equals get slope of coordinates at 0 and coordinates of 1. And then we can loop. Oh wait, Kotlin has a nice range. So we'll start at 2 rather. 2 up to the length of our coordinates. Size of our coordinates. Is that right? -1. Why are you yelling at me? Function invoke is not found. This is what I'm wanting to do. Alright, it's time for the googs. Lapis lazuli in her teeth. Save this one for later. Range loop. Okay. I in, there's the range. I don't like I really. C for coordinate. Okay, range 2 should be replaced with until. Okay. For C2 until coordinates that size, it removed the 1 for me. So that's nice. Okay. What's the problem here? Oh, empty body. That's fine. Okay, so basically. You need to get the slope of C. You know, we don't have to get the slope of C, do we? You know, I'm getting all confused now. Do I have to get the slope, or can I just check if it's collinear and give... No. No. All wrong. So I have to get its slope. Which means I have to pass 2 numbers, which is pretty yucky. So which 2 numbers should I pick? I guess I might as well just compare with my first number. we'll just keep doing that. So check our first pair of coordinates and whatever this one is. C is an int. Oh, right. Coordinates. Let's see. Alright, well now I like it as an I. Alright. So we'll get the slope. Call base slope. And then if is collinear, and we can pass slope and base slope. So it's awkward. I don't love my function names. I'm gonna call this our slopes collinear. Kind of a weird question. That's okay. All right. If they aren't collinear, then we can return false. No need to continue. Then otherwise we return true. Okay, there we go. Ah, that's why it looked weird. There we go. Sorry, C# creeping back in. So let's do one more test here. Test, just to make sure. Change that name. So what are we going to do here? We're going to pass it an array of arrays. Array of, and let's do 1, 2, and 3, 4, and just see how that goes. All right, fine, one more. You twisted my arm. Let's make it a little bit more interesting, like 10 and 11. All right. And I'll say dot map dot to int array, sure. And then this whole thing needs to be an int array. No, the whole thing is just an array of int arrays, so that should be good. I don't like R. Coordinates. Coordinates, okay. A list. All right. And is that true or false? This is true. All right, cool. Let's test not a straight line. Hey, oh yeah, I didn't fix my test. Oh, that's good. Maybe we'll test one out of order. Not that it matters, but hey, why not? It's cheap. Call this out of order, non-straight line. Okay, we could try negatives. Negative. Try negative straight line, so I don't know. Maybe -1, 1 and 1, -1. That should be true. Okay, hey, all tests passing. Run them all again just to make sure, but I think that's a good solution. End time. Yes, it is end time. I am calculating some things more than once, which is not great. I mean, I keep looking at the same coordinates over and over again, which is just kind of weird. So I think I could probably do something here where maybe I start at, I don't know, 3 or something. Start at 3. I don't think it matters. It's not really worth it. I mean, we could basically start a little bit later and have this be 2. Is that correct? Let's try it. Oh, nope. For I and 3, I'm comparing to 2. We should get the slope, and then I want to check that the slopes are collinear. So why didn't that work? I and 3 until. Huh. Why wouldn't that work? That is curious. I'm okay with it not working. I do not working stuff all the time. I just don't explain. I don't understand why it doesn't work, which I don't like. Oh, hey, got another sound. I have no clue what it means. Hopefully it was a good one. Not reported for copyright. Okay, well. I started at the second one and then started at the third and moved on. 2 to 3 should have the same slope as 0 to 1. Oh, if I do that, I'm never checking. Okay, yeah, I can't do that. I'm never checking 1 to 2. Okay. All right, there we go. Let's try it. First submission. It's going to work. And got to reinforce something that I didn't know. Oh, yeah. Forgot about this. Eesh. It's harder. All right, I'll come back to that. ADD. All right. Here it goes, drum roll. And I expect to do pretty good. Yeah. Looks like there's 3 main solutions. Slower one gets the slope. Gets the slope. And they actually do the division here. So it effectively handles the reduce. So they didn't see hint 3. This one ran faster than mine. Diff to float. They're doing the division also. And the absolute value. So this is the approach I was thinking of before I saw the trick about the cross product. So this is what I would have ended up with, and it's just yuckier. So glad to see that hint. Thank you, leak code. And here's the best solution. Coordinates at what? If coordinates at 0 at 1 is equal to coordinates at 1 and 1. What? What is this? So they're checking the y coordinate of the first item and the second item in the array. And then they loop through the rest of them and they look to see if they all have this the same value. So if it's like, if your y is a 3 and your y is a 3, then we know that you're a vertical line, so make sure that everything is vertical. Okay. So that's kind of a weird thing to check. It's like, make sure it's not see if it's a vertical line, otherwise return false. But in most cases where these aren't equal, it'll just skip down to here. It was kind of weird, like it's just throwing me off, like why even bother having this? Like presumably this would handle that situation where these two things were equal. So, alright, anyway. So then they get the slope of the first one, they float it, they divide, and they loop from one until, and they do the math, and then, so, yeah, so it's basically the same thing, they just end up doing math. So I'm surprised that the division worked faster than the cross product, especially with all the casting and stuff. So I don't love that. I don't love that it was faster than my solution. If we go back to problem and look what people have to say about it. No division by 0. Wow, that's a slick answer. Get the coordinates 0, get the coordinates 1, figure out the slope, get the, sort of they minus it for that. I don't know what XP means. What? And then they check to see if the difference in X times your number and the difference in Y of your number is not equal to XP. So they do the subtraction. So I'm guessing the minus takes care of the reduction. It's just strange. Wow. But wait, what about vertical lines? Hey, yeah. Okay, so that's why that answer we looked at checked for vertical lines, because it ends up being divided by 0. And they handled that with a minus. Okay, so that's cool. So this is really slick. Hey, this same equation can be derived if you take the cross product of the vectors. That's cool. Alright. Question mentions that repeated points won't occur. Okay. Very nice. Thanks for the write-up. Okay, well, hey, happy Friday. That ended up being pretty cool. I think this weekend, doing podcast recording on Saturday, so probably won't be a long code day, but I don't know, maybe Sunday I might do something fun, just kind of, I don't know, just do something fun. Maybe play around, maybe do a web app or something. It's been a while since I've done anything with graphics, maybe even Unity. I don't know. I feel like doing something fun. All right, cool. So that was easy. Was it literally listed as easy? Let's see. This is my super top secret way to check. Yeah. Okay. I like that one. That was cool. Would have been much nastier if I didn't know about the cross product, if I hadn't seen that hint. So glad for that one. These two hints kind of seem extreme to me, but I guess, I don't know, maybe people don't remember the high school math for that. So, all right, that was pretty cool. Well, I'm going to get out of here. Maybe more Overwatch. All right, we'll consider this one slaughtered. Have a good one.